Hi, welcome to video 1.2, Introduction to Functions, and we're on page 4 of your lime green packet. So we are actually going to start with this one down here because it's a little bit tougher. So I'm going to do the tougher one, and then I'm going to have you do the easier one by yourself. So these are different ways that we can represent functions or relations. We can do a table, ordered pairs, a graph, or a mapping. So what we're going to do is this little part is to show your work, which you can use or not use. It's up to you, but I'm going to use it to show you what I'm thinking. So I'm using this function up here, and instead of x, x is now -3. So I'm going to put in plus 1 squared. So -3 plus 1 is -2, and -2 squared is 4. -2 plus 1 squared, that's -1 squared, which is 1. If I have -1 plus 1 squared, that's 0. 0 plus 1 squared is 1, and 1 plus 1 squared is 4. So that makes my ordered pairs. I use my x and my y, so I've got -3, 4, -2, 1, -1, 0, 0, 1, and 1, 4. Then I'm going to graph them. So -3, 4, -2, 1, -1, 0, 0, 1, and 1, 4. And then here's what my graph looks like. This is called a parabola, which you will be really familiar with by the end of the year. And so my mapping looks like this. I'm going to put all my x values, and then I'm going to put my y values. My y values are 0, 1, and 4. Those are the only ones I use. So -3 goes to 4, and 1 goes to 4. -2 goes to 1, and 0 goes to 1, and then -1 goes to, and then, -1 goes to 0. Okay, so a function is a relationship between a relation's x values and y values, and a relation is a function if there's exactly one output for each input, which means only one y for every x. And here's what that means. So moving on to the next page, we've got, if we have ordered pairs or table or mapping, what we're looking at is the x and y's and whether they repeat. So the way that I explain this is the x's are like, this helps me remember, the x are the dogs, and I can remember that because another word for x is the domain, and domain and dog both start with D. And then the y is the owners, and another word for y is output, which starts with an O, just like owners. So these are my owners, and these are my dogs. So it is not okay for a dog to have 2 different owners. So some people may know of a time when that happened, but it's not very likely. However, it is okay for an owner to have 2 different dogs. So let's look at this one here. We have the same dog. So the 1 is the dog, and it has one owner here, -2, and a different owner here, 5. So one dog cannot have 2 different owners. If it does, that makes it not a function. And then if we're looking at a graph, we use what's called the vertical line test. Vertical line test. So if I take my finger or a pencil or pen or whatever, and I draw a line, if my line touches my function or my relation more than once, like right here, if I'm drawing down, it touches once and then it touches again, so that is not a function. So if no vertical line can be drawn so that it intersects the graph more than once, then it is a function. This one can't. If I draw a straight line down, it touches it twice, so this one is not a function. Okay, so you're going to practice telling whether things are function. We're going to do the first 2 together, and I'm going to talk about domain and range, and then you are going to try some on your own. Okay, so this one right here. We're going to look and see if it is a function. So I have 2, 3, 3. So 3, this is the same dog, but it has 2 different owners. So that is not a function. Okay, for domain, all we do for domain is put all of our x's. So we have 2 and 3 are our x's, so those are the only things we have as our x values. For a range, we're going to put the things we have as our y values, so that would be -2 and 1. And we put them in order from least to greatest. Okay, let's try another one. So here we have the same dog. You can see the 1, and it has 2 different owners, so this one is also not a function. Our domain, we have 1, 3, and 5. So that's the values in our domain. And our range, we have -4, 2, and 4. Okay, please try number 3 and 4 by yourself. Pause the video while you do it, and then come back and take a look at your answers. Okay, there are answers down at the bottom, so you can check your work. And let's try one on page 6 together. We're going to do number 5, and we're going to do number 7, and then you are going to try 6, 8, and 9. So let's do number 5. First of all, is each dog has a different, there's no dog that has 2 owners. We do have an owner that has 2 dogs, but that's okay. You can own more than 1 dog. So this one is yes, a function. Our domain is just going to be the numbers that are written over here. So -1, 3, 5, and I'm going to squish -2 over there because that should be before the -1. Okay, and over here we have -3, -2, and 4. Okay, let's take a look at one when we have a graph. So for a graph, remember vertical line test. If I draw a vertical line, I hit this relation more than once when I draw a line. So this is not a function. Okay, now this is a little bit different. So my x, this is continuous. X could be 0, and it could be anything above 0. I'm going to use everything from here on out. So I'm going to write x is greater than or equal to 0, because it could be 0 or it could be anything bigger than 0. Also, my y, if I look at my y and I keep going, it could be anything there and it could be anything there. I keep going down, it's going to hit every y eventually. I keep going up, it's going to hit every x or every y eventually. So this is all real numbers, and if you don't remember, we write all real numbers like that. So go ahead and try 6, 8, and 9, and I'm going to tell you that domain and range are usually difficult for people, so if you are struggling with domain and range, don't feel bad. We're going to work on it in class, and all will be okay. Just do your best right now. So pause it while you try those, and then come back and take a look at the answers. Okay, here are your answers for 6, 8, and 9. So there's 6, 8, and 9. Make sure you're writing down any place where you're confused as to where the answers came from so we can talk about them in class. Okay, let's do these right here. So we've got a function, f of x equals x plus 2, so we can just do -2 plus 2, and that would be 0. If I put -1 in there, that's going to be 1. 0 is 2, 3, and 4. And then I can draw my points. So 0, -2, or I'm sorry, -2, 0 is right there. -1, 1, 0, 2, 1, 3, 2, 4. And this is not just discrete points, but it's actually an equation. So we're going to draw that going on forever. Okay, now f of 0. So that means when x is 0, what is f of x? It's 2. When f is 1, what is f of x? It's 3. When f is -2, it's 0. F of -1 is 1, and f of 2 is 4. Now these are kind of backwards. This is saying what the whole function is, and it wants to know what value do we put in for x to get this value to come out. So it's saying when the whole thing is 2, what did we put in to get that? It's 0. Same thing here. When I have 1, what did I put in to get that? It's -1. When we have 4, it was 2. And when we have 0, it was -2. Another way to do that is I can look at the y. So here's y equals 2. What is x at that point? it's 0. Okay, this right here is a continuous function, and it's because it's connected, and its domain is going to be all real numbers, because if this keeps going and this keeps going, it's eventually going to hit every possible x. Same thing with range. It's going to keep going up, it's going to keep going down. That means that my range is all real numbers. Okay, let's look at one where we're looking at like a situation instead of just a graph or an equation. So our friends, we decide to go to the movies and buy some popcorn. Each bucket of popcorn costs $5. Complete the table. So if 0 friends buy popcorn, it costs $0. 2 friends buy popcorn, or 1 friend buys popcorn, it's $5. 10, 15, 20. And then we just put that on here. So 0, 0. I'm going to make my y values 5, 10, 15, 20, so we can fit this on here. And I'm going to leave it points. I'm going to come down here first, and I'm going to say that this is a discrete function. And the reason that it's a discrete function is because I'm not buying no half buckets of popcorn. We're not going to buy like 1.5 buckets of popcorn for $7.50. So no half buckets, no fractions, no decimals in there. Okay, so if I buy 1 bucket of popcorn, it's $5. 2 buckets or 5 buckets of popcorn, $25. Okay, here's the weird thing. If I were to buy -3 buckets of popcorn, then it would be -15, like if I'm following the situation. However, I can't buy -3 buckets of popcorn. So on this one, the real answer is no solution, but I would probably accept -15 on like a test or quiz situation, as long as you explained your ideas. Okay, so f of x is 20. That means that x is 4. 4 buckets of popcorn. Here, $35 is 7 buckets of popcorn. Okay, my domain is going to be real positive, so positive whole numbers. And my range is going to be multiples of 5, because I'm not going to have anything else except multiples of 5. Okay, you try the 3 on the back here. Pause it while you do it, and then come back and check your answers. Okay, here are your answers to the last few. Oops, I'll let you look at those first. And then moving it down to the last one. Okay, please write down any questions that you have so we can talk about it in class, and I'll see you then.